Hey, so we're going to get into something today that sounds super simple, but is actually a life or death question for millions of people living near the coast.
Seriously, think about it for a second. When you see water on the road ahead, at what point do you turn around? Is it an inch of water? A few inches? Maybe a foot? When does a road trip turn from just an inconvenience into a real, genuine danger?
Well, it turns out the answer is way more complicated than you'd think. And for folks in coastal towns, that line between passable and perilous is getting blurrier all the time. Getting it wrong just isn't an option. So let's dive into the science that's trying to make that line crystal clear. Okay, so first things first, we've got to wrap our heads around the sheer scale of this problem, because we're not just talking about a few low-lying streets that get a bit soggy. Check out this number, 96,560 kilometers. That is the length of roads in the United States that are already exposed to regular coastal flooding. That's enough road to circle the entire planet more than twice. And get this, that number doesn't even factor in future sea level rise. Yikes! But the problem just kind of spirals out from there. A single flooded road isn't just a detour, right? It can completely cut off access to a hospital. It can trap first responders. It can turn the one evacuation route out of town into a total dead end. And tragically, about half of all deaths related to flooding actually involve people in their vehicles. So to figure this out, scientists needed to find a place that lives with this threat day in and day out. They needed a real-world lab where they could test their ideas against the raw power of the ocean. And they found it right here. This is the Battleship Parkway, what locals just call the Causeway. It crosses Mobile Bay in Alabama, and it's a super critical artery for the whole region. But its location makes it one of the most vulnerable spots in the country. You see, this area is basically a magnet for extreme weather. I mean, hurricane after hurricane has slammed this coastline, and all those storms, while tragic, have given researchers this incredibly rich history of data on exactly how, when, and why this one crucial road floods. Okay, so you've got the perfect location. But how in the world do you take years of chaotic storm data and turn it into a clear, simple set of rules for when to close a road? Well, you need a blueprint. And this is it. This flowchart is basically their master plan. It's a framework they built to merge the virtual world of super powerful computer simulations with the hard, wet reality of what actually happens on the ground during a flood. Let's break it down real quick. So, step one, they built a digital twin of Mobile Bay, basically a super detailed computer copy of the whole area. Step two, they fed that model tons of real-world data, tides, river flows, storm conditions, the whole shebang. Step three, and this is the really clever part, they compared their model's predictions with the actual historical road closure records. And finally, step four, they unleashed machine learning to find all the hidden patterns in that mountain of data, which let them create brand new, much smarter rules for road closures. So, what did all that number crunching and modeling actually spit out at the end? The result is a surprisingly simple, clear system for understanding flood risk as it's happening. By layering their super smart model on top of all that historical data, four really clear categories of flooding just emerged. This wasn't guesswork. These patterns were pulled right out of the data itself, showing exactly how different water levels led to real-world consequences. And here they are. You've got low severity, which is less than 4 centimeters. You know, your tires get wet, but you can probably pass with caution. Medium is up to 10 centimeters, and that's where you might start seeing some lanes closed. High goes up to 20 centimeters, making it pretty much impassable for most regular cars. And anything over 20 centimeters, that's about 8 inches, means a mandatory full closure. It's just flat out unsafe. And now we can see this system in action. This map shows the causeway during Hurricane Ida back in 2021. The model can pinpoint almost down to the foot which parts of the road are in the most trouble. You see those purple areas? That's where the water was over 20 centimeters deep, a mandatory closure zone. This is the kind of predictive power that can literally save lives. But wait, the model gets even more specific, and this is where it gets personal, because the road is only one part of the danger equation. The other part is the car you're driving. You see, it all comes down to this thing called ground clearance. It's just that little bit of space between the bottom of your car and the road itself. And that small space can be the difference between driving through a big puddle and your car getting swept away. And here's why that matters so much. Just look at the difference here. A road with, say, 15 centimeters of water, about 6 inches, might be totally manageable for a big 4WD vehicle. But for your average sedan, that exact same depth is well into the danger zone, risking serious engine damage or, even worse, losing control of the car entirely. So what's a minor nuisance for one driver is a full-blown emergency for another.
Now, this whole framework is an amazing tool for managing flood risks today, but its most powerful and honestly, its most sobering insights are about what's coming tomorrow. Take a look at this chart. That blue line way down at the bottom, that shows today's normal water levels. Now, look at those shaded green areas. Those are the projections for the future. By the year 2100, a completely normal high tide could be reaching levels that, today, we only see during a major hurricane. Let that sink in.
The researchers who did this study put it perfectly. They said that what is now an occasional event, what they call episodic flooding, is on track to become a constant state of being, chronic inundation. Our roads won't just be flooding during big storms, they'll be flooding every time the tide comes in. And that leaves us with a really critical final thought. This science gives us incredible tools to manage the risk we face right now, but it also gives us a pretty stark warning about the future. If the worst-case storm surge of our lifetime becomes the daily high tide for our kids, what do we do then? How do we even begin to prepare for a world where the roads are just always flooding?